Thank you for having me back so soon. Last time I was here, I was talking about low-level development, memory layout and stuff. This time we will go high-level development, abstraction, API design. So this is something I hope you will enjoy. This is me. I am principal software architect at Tobii, currently building eye tracker software. And I'm general nerd. And I've been doing C++ for a long time. Now I'm doing more and more Rust, actually. But yes, I heard that, Harald. Correct answer is Swift, if you ask Harald. We will go through some API building principles. We will go through some error specifically in APIs. How do you handle error reporting from APIs? Then we will look at, very briefly, something I called API flavor. I will get back to. Let's start with principles. But before that, let's do a little bit of API warm-up. This is an API. Might not be the biggest API. So let's talk about what is an API. Well, it's sort of a set of functions and data types that go together, right? It's some kind of cohesive whole. Yeah, OK, this maybe is a stretch that this is API. It's a small subsection of an API that has to do with memory stuff in C. But let's just humor me. OK. So let's do some warm-up. Can we improve this? I mean, this has been around for some time. We've learned some stuff as an industry. We should be able to do something to this, right?
It's redundant. Reality does all you need.
Oh, yeah. Well, first thing we can look at here is there's a weird asymmetry here, right? One is called malloc, and one is called free. And that's curious. Why is that? Actually, there was mfree. There was an mfree function once. In 1973 version of Unix, the mfree function freed map objects. And malloc is not memory alloc, or used not to be. It was map alloc. And map was a data structure that allocated on physical, like persistent storage, I guess tape back then, I guess, and also in working memory. So map alloc and map free were two functions. And of course, for reasons unknown, the mfree went away. So now it's malloc and free, and malloc, of course, allocates memory. But we really should have some kind of symmetry here, I think. And then we say size here. Size, right? Is it words we're allocating? Is it bytes we're allocating? What are we allocating? I mean, you might think this is obvious, but it's, imagine you're coming to this fresh. So maybe let's just not repeat ourselves. Maybe be very explicit. We have like a size, and it's bytes that we're giving it. OK, that's nice. Well, this is still a little bit awkward. How about this? Allocate memory, free memory. Reads nicely. This is how you talk. If you talk to your peers, your coworkers, this is what you would say. You would say allocate memory, free memory. And writing code is talking to your coworkers, right? Or maybe yourself. But here's sort of our first trade-off. Because if we do this, it reads nicely. But there's a problem. We don't have memory, or we don't have namespaces in C, right? So we need to namespace it somehow, and we typically do that by prefixing. So we're sort of forced into this memory allocate, memory free. Still better than free and alloc, I think, but maybe question. All right, what else can we do? Maybe no discard. If you allocate and you don't do anything with it, probably a bug, right? So why not let the compiler warn us about it? But there are some things we don't see here. How about initializing the memory? Is it initialized? Is it not initialized? How about error reporting? What happens if you can't allocate? How is that reported back? All sorts of things like threading guarantees. There's a lot of things we don't see here. So maybe there's something we can do to make at least the initialization. I mean, Safety is paramount, right? This is something that we've, as a C++ developers and C developers, have sort of grown to learn over the last few years. We need to be safe by default now, not fast by default. Maybe this. Now we're stretching the limit here. If this is a good thing, or now we're talking about trade-offs, really. Memory allocate uninitialized, memory allocate, yeah, maybe. I don't know. This is a little bit fringe, maybe. This was a warm-up. Are you warmed up? Have you started thinking about API design now? OK, good.
The memory is aligned as well, so maybe that should be part of the name.
Aligned? I mean, 120 is the new 80, so don't fear the long names. Let's look at some principles of good API design. Now, these are, I'm going to show you some principles. These are the only principles you will ever need for API design. No, I'm just kidding. These are some random ones that I picked. There are, of course, many others that I won't be covering. So don't take this as like the one and only thing. But one thing is consistency, like we saw with the M-free, alloc. It's nice if your API is consistent. If it is consistent, it is predictable to your users. And it's also like consistency reduces the information content of the API, the unnecessary information content, which is nice because it's complex enough as it is. So what is this consistency then? Let's have an example. Spelling. I told you this was a high level. Pick one. I don't care. Pick one. Because if you are typing and you have to, oh, was this spelling? Was this spelling? I mean, this is a small convenience thing in the category of consistency. Yeah. You're right, by the way. Symmetry is another thing that is important. If you have like two things and they're different, like maybe you open a file and then you destroy the file. No, don't do that. You open a file and you close the file. We have opposite words. You create something and then you destroy something. You open and you close. Try to find these opposite pairs to like balance things. If you do the same thing in different ways, try to use language that lets your user understand that you're sort of doing the same thing, but in different ways. We will have some examples of this as well. At the rate I'm going, I think this is going to be short talk. I don't know, maybe predictable. There are, of course, things your API will do. It will turn on a light. It will do things. It will report errors. Some of these things will be hidden from your user. If it throws an exception, for instance, it's not obvious. And there are other things that you will do that can be idiomatic or not idiomatic. So there's a lot of things you can do to make your API predictable. So let's look at an example of this. Here's our friend vector, std vector empty. Now, if I ask you, who in here knows if this is a void return or bool return function? OK, so OK, maybe you've seen this as belabored example. But what if I tell you that there is a clear function? You can see already here, we're back to naming. Maybe empty was not the best name. How about is empty? Yeah. Is, has, can, all good prefixes. How about, again?
There is also this, if you have unique pointer and you have reset and release, which at least I have confused sometimes.
Reset and release, excellent. Yeah, feel free to shout out as well if you have other reflections like this. Excellent. I mean, to be fair, std vector was designed by the brightest and best C++ developers, and they screw up. So will we. But at least now we can learn from their mistakes, right? A good API should be complete. This is a little bit maybe more nuanced than the other ones. The other ones might be a little bit clearer. A complete is something that doesn't have any holes. It has all the required parts. It doesn't have any extra parts, but it has all the required parts that it needs. Even if some of them don't get used all the time, or maybe even ever, it's still there for completeness. And there are actually a few different reasons for things to be complete. We will look at a few different examples of why we should strive to make things complete. So first, const completeness. Who doesn't love const, of course? If you ever implement, for instance, an index operator, you know this already. You should have a const index operator so that you can operate on a const version of your object. It doesn't need to be exactly identical. It can return some const reference back, of course, because otherwise you would sort of be able to reach into it. But this goes to a lot of functions that you can have. Consider, should you have a const version, or maybe should you have a non-const version? Maybe the const version should be sort of your default, actually. So this is a completeness, const completeness, which is good if you can provide in your APIs. Safety, completeness for safety. Okay, what's that about? Who has seen this in their code base? Who wrote this in their code base? Maybe I don't even remember. Maybe I did. What is the problem here? Does anyone want to shout it out?
Destroyed immediately.
Yes. We were creating a lock that's supposed to lock something as an RAII pattern, and it's destroyed immediately since we don't introduce a new variable. This is a sneaky thing. You need the lock. Otherwise, it's just gone, right? Of course.
There should be a no discard on that object.
Thank you. There should be a no discard on this constructor. You can put no discard on your constructor. And for all your RAII, okay, let's say it together. Everybody with me. RAII, thank you. There should be a no discard on your constructor for those types. I'm not even going to say it anymore. I'm just going to say the thing yeah. Another thing for safety, explicit. For every single argument constructor you write, ever, from this day on, it should be explicit, unless you want to do some real funny business. This is unfortunate bad default. We just have to live with it. But this is part of being complete, having your API to be complete. If this is missing, it's not complete. That's what I'm talking about, completeness for safety. There's also completeness for performance reasons. So let's look at that. If you define an API and you have some kind of data type here, document data type, nice. We like documents. I used to work with C#. And then you have a vector of documents, as you would, and you push it back. Okay, I'm going to ignore there's no place back here. Just don't get hung up on that. We're just pushing back some documents. Wouldn't it be nice if we could sort of move it in, maybe? Here we come to the rule of 0, rule of 5. This is also in the category of completeness. You should have either 0 or 5 of, or 3 if you're unfortunate and still live in, yeah, I won't even make fun of that. Oh, sorry. Time travel, okay. You should have a 0 or 5, of course. We know this, but this is not really the reason for this slide. That's just an accidental point I'm making. what happens when you do this? You push back, and eventually it will trigger a realloc. And then you think, great. Good thing this heavy-to-copy object now has a move constructor. You dodged that bullet, but you didn't. Because there's a quirk to vector that unless you make the move constructor no except, it won't use it. So make your move constructors no except if you want it to be used by vector. And this is because vector has a very strict exception safety guarantee. So it can't really, if your move constructor throws, it can't uphold its exception safety guarantees. So it looks for this using some type checking. So this is, yes?
Sorry, I just have a comment. C++ is very consistent in its having the opposite defaults.
Yes, it's consistently wrong defaults in C++, but we still love the language, right? Yeah. No, it's fine. It's just you have to type a lot, but typing is good for you.
Start with all the keywords and you remove them one by one.
Yeah.
If there's nothing there, then it's like a very special method.
Yeah, it's a very special method if you don't have no except on your move constructor. Yeah. Don't do that. So yeah, but for performance reasons in this case. So completeness again. Completeness means typing. Now I seem to have skipped ahead. I seem to have skipped ahead.
Inconsistent slide.
All right, don't worry. I was just doing some final editing on this before. We will see where it takes us. I'm as surprised as you. An API should be fluent and safe. And fluent, let's see if there's an example of this. Otherwise, I will wait until there is an example of this. No, safety. Damn it, last-minute edits, cursed. Let's look at safety instead. Your API should be safe by default. I would say this even if it carries a small performance hit, typically. Depends on your, I mean, still controversial, I understand. But I mean, even now since Clang or LLVM standard library is starting to introduce some runtime checking and so on, it's like, yeah, we're going to a safer place, I think. So let's look at some safety things. Vector again. I love to pick on vector because who can sort of take offense? Is this safe code?
No.
Why?
Because you should use at if you want safe and you should use brackets.
Okay, interesting. So this is, it should use at, you say. Maybe like this. This first one does no bounds checking. It's just basically the array semantics, right? At does bounds checking. Has anyone used at? Is anyone currently using at?
Today.
Wow. It's not always available. This was much more than I'm surprised that so many people are using at. Because, I mean, I just look at it. But still, it's good. It's the right thing. Thank you. I appreciate it, but it's still surprising to me. What's that? Oh, there are bounds checking. You can turn it on with define or something. Yeah. So you can get bounds checking for the first one. Nice. But there is something a little bit, I don't know, awkward about this situation, right? Let's ignore that this is actually the reality. Let's go to our happy place, a separate reality, and see what we can do. First, I don't think it's very predictable that .at is actually thrown an exception. There's no way it says like at. It does not mention bounds checking at all. It's at what all. And it's one is using these hard brackets, one is using these soft brackets. That's not very consistent. It does the same thing, but it's very clunky. It's not pretty. I want pretty code. How about this? Let's say we can add bounds checking to the first one. Let's say we can do that. Let's say we can get an option where we don't have bounds checking. We have direct access for your tight inner loops, right? You need that sometimes. You still have the data member, right? You could do something like this, I guess. Still, I mean, right now it's at least it's sort of consistent. You have the index operator twice. So that's a little bit better, but it's still not very predictable. It doesn't really say anything about bounds checking. How about this? Now we're getting somewhere. This is what the API I would like to see. Now it's consistent. You have the hard brackets. You see clearly that something is unchecked. By symmetry, if there is something that is unchecked, your brain will automatically think there is something that is also checked if there are two things. So we don't even need to put .checked on the first one. I mean, you have to be careful with this because it's not always as obvious. But by symmetry here, we can sort of infer that the other one is checked. Yeah?
But
So,
it's still weird. For me, it would be more natural to say unchecked ed. Because unchecked
yeah?
position.
I mean, this is up for debate. This is not the end-all, be-all.
Should be a function, not a.
It should be function, yeah?
If you use brackets, you index into something.
Yeah, okay. In unchecked data access? No, maybe that's an awkward thing. This is the best thing about API design, right? There's no, like, this is the actual way to do it. There's a continuum of, and you have different opinions and so on.
Taken to extreme, how would an unhinged API behave?
An unhinged API. Dot unhinged. Yeah, I don't know. This is, let's have a little bit of a sip of this and we'll find out.
I think an important missing feature here is the distinction between bounds checking and have a runtime error versus bounds checking and have to terminate.
Yeah,
And I think it's kind of reasonable to terminate if you're out of bounds.
yeah.
One of these cases.
Anyway, solved by comment, right? Let's move on. This was, yeah, unfortunate reordering again of the slides, but this is another example of safety that we're going to get to now. Now you can get even more involved here because this might even be more open for discussion. I'm calling it rich types, but it's just a fancy way of saying use the type system. It's C++. It's a typed language. We can get help from the types. Let's look at this. We have a rectangle. It has a width and a height, 2 int arguments, and we construct one. Nice, right? But at the point of where we construct it, we no longer have the parameter names. We no longer know if it's width height or if it's height width. Classic. I mean, there are many ways to solve this. The very lowest effort way, this is the least over-engineered way to solve this, I think, is to introduce what we in Rust call new type pattern, but it's much more convenient. No, I'm just kidding. It's you have these tiny types where you just have a wrapper, a new type introduced to wrap another type. And you take those arguments. Of course, these types can be more complicated here. Maybe you want a value function that returns the value. Maybe you want some other stuff. But this is sort of the least effort thing, I think. Very important that they're explicit, again, single argument constructors. Because what happens now when you construct one, a rectangle, is that you need to specify the types. And the overhead of this is sort of negligible, I would assume, on a modern compiler. So here it's no longer possible to sort of switch them out.
What about the overhead of this implementation?
I would argue if you just have a single value like this, there is no overhead for a modern compiler. But please check me.
But
You can't really pass structs as arguments as efficiently with the API, I believe.
I think the compiler in this case will just.
It can be optimized.
Yeah.
But by the API, it needs to be passed.
I think the bigger problem is that these are not.
Type talks years ago, where Björn showed in Compile Explorer that there is no overhead.
I think especially if you construct them.
Depends on the platform.
Yeah.
If you're on Windows, it costs. If you're on anything else, it's free.
Yeah, okay. But I think especially if you construct them in the like R values in the call site like this, you have a very, I think, good opportunity for the compiler to actually get rid of them. Now we're 2 people at a time. You first.
Here in that example, actually, type are very simple. Can you directly use the name of the field?
I mean, yeah, you could do dot val if you wanted, but that sort of also obscures a little bit.
No, he's talking about
Was rectangle.
the C++ 20 thing when you reference the values in the struct directly.
Is it designated initializers?
Oh,
Yeah.
yeah. I mean, there are fancy ways to do this. This is sort of the least fancy way to do this, but still get sort of help from your type system.
Yeah, one other problem with it is that this runtime doesn't behave as an integer. It's nice if you did pass it to
Yes.
the limit or
Yeah.
numerical limits.
This is just a way around not having named arguments, I think.
Yeah, it is basically a way. You might think like, okay, let's use using or typedef or something, but that doesn't work because that doesn't introduce a new type. And unfortunately, introducing a new type, it's actually introducing a new type, which is sort of to your point that it's not actually behaving exactly like an integer. You can make it behave more like an integer, but it's not going to be one. But at least you can make it one of these, what's it called? Standard types, the basic ones. I take your question for now. Well,
Are you sure you want to tie the width concept to an integer specifically? I mean, I can think
this is
of
good.
many larger systems where you might want to have
Yes,
integer widths and double widths, for example.
of course. This is a good point. This is a good point. This is a modeling thing, right?
Risk of really exploding your type system.
Yeah, this is a modeling thing right now. Are we modeling width in general? Maybe that's not such a good thing. So you could have this sort of constrained in a namespace or something where it makes more sense. You could have it templated, of course. You could have, if you want to model width specifically, but typically you want to keep it next to the rectangle because this is sort of rectangle width in this case, I would say.
Which makes it really funky. If you want to have rectangle width 10, rectangle height 10.
Yeah, I mean, there are trade-offs, of course, yeah. Another thing that you can do to make it a little bit also maybe weird in this case is you can have these suffixes, what's it called, named literals that you can have maybe for width and height doesn't make any sense. But if you have like quantity and cost or something, then it makes maybe more sense to have these literal suffixes.
In this case, you might want to use them for units because
For units, yeah. Is it pixels, millimeters?
Would you use an X and Y type if you created a vec2?
No, I would use a point type.
I mean, if this was a vec2 instead,
Yeah.
like an X and Y, would you still do an X struct X and a struct Y?
No.
No. That's my point.
Yeah. No, this is not, don't do this every time. This is, I mean, this is one way to do it. You can use this. This is a tool in your toolbox. But it's like, I don't know, API design is like playing music. You don't just play it like a MIDI piano. You play it with some like, inspiration. So this is something you can do. It has its trade-offs, but it's not all the time. All right, moving on. We'll never get through this. Let's see about this. Add width. OK, here we just have one integer. Should we use the width type here?
Delta width.
Delta width. I knew width. I mean, We could. There are other options. We can have add width. We can add with an overloaded with width and height. I mean, I think we can agree that the middle one is a little bit add width. Seems excessive, right? Let's ignore the middle one. Show of hands. Who prefer add with int width?
You have to pick.
Yeah, you can vote for both, I guess, but that makes. Who prefers the last one, the overloaded add width? So we probably equal participation here.
I'm a control freak. I prefer the second one.
Yeah. I mean, I think both are fine. This is my thing.
I think there should be increased.
What about widen?
I'm just gonna move on here.
You should not be able to modify the rectangle. It should be value semantic.
This is the gold star, immutable type. It should return add width should return a rectangle, right?
Is it adding to the width, or is it adding a new property width?
Yeah.
What is
Why am I even here on this presentation? I should have a whiteboard here. All right. Now let's see. What did we cover? We covered complete and safe in the wrong order, but that's fine. Now we're moving into the fluent. This is also a little bit of a weird concept that I think is sort of you pick it up if you have an API that doesn't have this fluent property, it will annoy you. And there are some examples of this. I will show you one. This is not like all the examples. This is just one way to look at it. Let's look at this. So let's get back to the rectangle, right? We have a crop function. It crops something. It takes a rectangle as an argument, takes it by value, since it sort of behaves like a value type. Then the other argument is how many members do your struct has before you stop passing it around like a value, even if it's sort of supposed to be a value type. I think 2 is fine, probably. I don't know. This is my gut feeling. If it's too big, just make a constref of it. But then it doesn't look like a value type, like an int anymore. OK, moving on. Default bounds, just some kind of factory that gives you a rectangle, right? You want to combine the two. You want to crop default bounds. OK, so far so good. This is fluent. They work together, these two functions. How about you want to add some width and height to your default bounds before you crop? Now, this is OK. I mean, this is fine. But it's also a little bit clunky. Now you have to introduce this new rectangle variable that you need to operate on. I mean, it's what happens with it after you crop? It's still around in the scope. I guess you could, if you really want to confuse your peers, you could wrap it in sort of an immediately invoked lambda there to like return it, but don't do that. But I mean, not for this example. Maybe do that for some other example. Wouldn't it be nice if we instead did this, maybe? We return a reference to the rectangle, and then we can do something like this. Now we can use the R value straight away. We can like operate on the R value. I don't know. Some people are allergic to this type of thing because they've seen reactive extensions explosions and how hard it is to debug and so on. I still think this is sort of nice. But, was that? It got worse. Yeah. Up for debate.
Overload operator plus, and it's going to be nice.
Overload operator plus, OK.
Why don't we make the crop function a member?
There are plenty of options.
In the book Design and Evolution of C++, Björn probably uses something like this called the build-up patterns.
Yeah.
But this means that you need to wrap this one more time to return the stuff.
This is not a builder pattern.
This is typically used in the context of a builder pattern where you have something that you actually, instead of a rectangle, you have some kind of intermediate object, and then at the very last line, you build the thing you want to build. And then it's sort of the same thing. Another thing that's like can be good with this is that you can use some kind of lazy proxy, like Eigen, for instance, uses like all these operations on these matrices, and only at the very end it actually does things, and then maybe you can do some smart optimizations along the way. I mean, in this case, it's just, I think this looks nice, but this is my sensibilities of a sort of a fluid thing.
I mean, this is okay with values,
Yeah?
but as soon as you need to own resources,
Yeah.
this mixing of crop and building, this is,
Yes.
yeah.
I think this is a good point. This is okay with values. I think this is good with values, but as soon as there are complex resources that needs to be owned and so on, it's much more complicated. Then it's maybe not such a good pattern. Anyway, this is what I mean with fluent. You can think about this and meditate on concept of fluidity and be like water and all that. All right, moving on. Errors. Errors are something that you will have to report from your API unless you have an API that never fails, in which case I congratulate you. There are 3 ways to report errors, I think. 2 are good, 1 is awful. So let's go through them. First one, exceptions. It's good. This is how we typically do it in C++. This is sort of the standard way to report errors. The bad thing about exceptions is that it's not obvious that you're returning an exception from your function. It's not predictable, but it's still fine. Just document it. This is, yeah. It's also consistent for constructors, which is nice. So consistency again. You can also have state as an error. You call a function, and it says the error, and then you call what was the last error. And you might think, why would anyone do this? But then I give you error no, and we've been down this road. Just don't do this. Don't use state for error reporting. There's a whole range of issues that will come up. Threading and yeah, ignoring the error and getting some operation that you thought produces an error, and then you read it and it actually had another operation that produced the error, and let's not go there. I think everybody can sort of agree on this one. If not, shout out. The other one is a return value. You can return an error. This is a little bit problematic because it sort of uses up the return value slot. You only have one return value. You have many parameters, but you don't have sort of one return value. So then you need to be cute about it. Then you need to either have out parameters, which is painful for the eye. If you're on modern C++, you can use std optional or std expected. And I think there's a subtle difference here. Std expected is sort of, you have the value or an error. This is how I read std expected. Std optional is like you have a value or you don't have a value, not necessarily an error, but it's like not a value. So maybe do expected if you're actually doing an error. And I won't say anything about exceptions and state, but let's just have a quick look at this return thing. I think it's also quite nice here to be like explicit in your code, so it reads nicely. You can use your own enum to have like an error code, and then you can just define result and error. Again, like we have in Rust. So that you get the unexpected and the expected types very succinctly. I think this is good. Then you can write something like this. If the preconditions that we have a positive width and height are violated, return an error, or if not, just return something that will convert into an expected result with positive result, like this. I think this readable, totally acceptable. But now it's double height width, and we should probably have named types. But different topic, different slide.
So it's good that you constructed it to say explicitly this error, because I think it's not expected if you just do curly braces and hope that there will be return value optimization, there won't be.
Oh, I didn't even know that.
Yeah, Jason Turner has an episode on that.
Okay. If, on the other hand, if you return errors in such a frequency that that is a major problem, it just feels like that might be some other thing also. But good still, good still.
The question is also if we should be able to construct the rectangle with these values in the beginning. Like, isn't that a little bit too far down the road?
No, but this is good. We can have this. Now this is a very interesting question. Really good that you brought this up. Now we're taking double arguments. If we had the arguments from before, we could have like validation of certain invariants in those types, right? So you could never construct a width with a negative value. Very good. And then you could have this check, probably since it's a constructor, then you would have to throw an exception then. But, or sometimes I've seen a concept where you have the constructor actually doesn't do anything, which is sort of backwards if you're safe by default. But then you have like a static from method in your class that says like from this value, create something, and then you get the checking. Maybe you should do it the other way around, I don't know. From unchecked something.
What's your opinion on just documenting this in a comment, like saying that the width and the height should be positive, that's the precondition, and then whatever?
Yeah, my comment is the compiler does not read your comment, neither does your coworker. So it will not work. The only one that cares about your comment is Claude. And so I guess maybe some very smart AI static analysis will pick it up, but otherwise I don't think it's, yeah.
I think you could make the argument, though, that this is a programmer error, and that
Yes.
handling programmer errors at runtime is questionable, and
Yeah.
it should be panic or terminate.
I mean, you could make this some kind of compile time thing that you enable maybe not compile time, that's the wrong word.
Panic.
Yeah, panning thing, yeah.
I think about that when you create this even class error code, it becomes part of the public API. So any change to it will affect all the users of your API.
Yeah.
So once you create this, you must be very clever to design it in a nice way to not produce changing errors.
This is also another interesting thing that you bring up here. There are two schools of thought here when it comes to error codes. One is that you have more than one error code. One is that you have one error code. It's like type erasure. You have an opaque error code, something went wrong, which is, of course, very good for API evolution, because then you can change, you can introduce new error types. I mean, not exactly what you said, but it's still in that vein, that you give yourself some freedom, but then, on the other hand, the developer using your API doesn't really have a lot of idea about what went wrong. So my general thing here is, if the user of the API can take different actions, or will take different actions, have different error codes, if it's just because you happen to know that there were different things that caused error, then you don't need to have different error codes, because then it's more surface area to support in the future. So that's a good comment about error codes as well, yeah. All right.
In C++ 26, it is also pre and post condition.
I've heard about this. I haven't looked into that, but that sounds very nice. Yeah.
The bad way of doing interface or error code is to return a negative value, a negative double.
Yes. Don't do that.
But if you're in
Or null, by the way.
If you have to use plain C,
yeah.
I would still argue that having a negative error code and a positive real code is better than out argument with a pointer, which just causes bad stuff to happen.
Yeah, I don't know if you
like if you have send and receive and similar things that return negative when it's error, I think that's still better. It's still better than having a error code return and pointer result.
Yeah.
Do you have long jump in C?
All right, let's move on. Otherwise, we'll never get through this. API flavor. Okay, this is very, very short section. Then I'm done. This is sort of, after meditating on API design for a while, I've sort of come to the conclusion there are 3 types of APIs. Exactly 3 types, nothing else. This is another categoric thing. You have stateful APIs, you have functional APIs, and you have side-effective APIs. I will sort of get to what that means. But basically, it's nice if you can sort of stay in one of these boxes. And it's nice if you can move as much as possible to the middle box, actually. But it's not always possible, because if you move everything into the middle box, then you're just sort of heating up the room. So, stateful APIs typically have to do with state, of course, with mutable state and upholding invariants for mutable state. These are your databases, your UIs. UIs are incredibly complex. Mutable state. It's very complex. It's about maintaining consistency, invariance. It's about like threaded access. Do you have an AP or a CP system? Can you like eventual consistency? There's locking. Everything that is very hard with state is still sometimes useful, because it's, I mean, a UI is mutable state. You have to do it somehow. But that's one type of API. And typically you will see in your API that there are a lot of nouns and adjectives and very few verbs. So try to sort of isolate that. Functional, of course. This is where you have like data in, data out. You have immutable data. Typically, you don't have this mutable state. And it's just very nice and like a joy to work with. It's easy to test. It's predictable and so on. Side effective is where you have the side effects as the main player. This is where your API actually does something, typically in the world, an IoT library. It sort of reads the data from the world. It turns on a lamp or something. And here you can say, this is sort of the stateful API, only that the state is the real world, sort of. And this is, of course, something you need to do, but it's also like error handling, again, like we touched on last, becomes like main thing for this type of API. It's a super important part, where it might, for a functional one, be like more, less complicated. So I think it's helpful to think about, okay, where, if you're in a large code base, you have a lot of different APIs. So it's helpful to think about, okay, this is stateful. Let's try to sort of make that a fully stateful thing. If you have functional components, let's try to maybe break them out and make this like a fully functional component. So I think this is a good way to tease apart your APIs or your code base. And that was the only remaining slide. We made it to the end. Thank you very much. Really appreciate this back and forth here. Any further comments or questions or suggestions?
I think the width and height should have been an asserts.
The width or height should be?
An asserts.
Ah, asserts.
Yeah.
Mm.
I had this up in the toilet.
Yeah, okay. No, that's fine.
What's wrong with negative areas?
Now we're into too much of a complex area. I can't even, yeah?
Would you advise to change an API to make it more aligned with your principles that you have?
I mean, API evolution is another topic as well. Has anyone ever seen this API? In that case, yes, change it. Has anyone seen it before? Maybe I said that wrong. If someone has seen it, then changing it requires thought, and there are a lot of other patterns to do that. But
you have to deprecate
keywords. Yeah, I could have another talk about API evolution with like how to introduce new functions and deprecate old ones. And there's this strangulation fig pattern that you can use to sort of and versioning, and yeah, it's
Hiram's law.
Yeah.
Can you make it for next time?
Now someone else have to talk next time. No, I'm done. But anyway, I enjoyed this immensely, so thank you for listening.